All right, welcome to the deep dive. We're diving right into a study fresh off the press. This one, it's called Self-Regulated Learning in the Digitally Enhanced Science Classroom Toward an Early Warning System.
Ooh, that's a mouthful.
It is from the Educational Psychology Review, published just this past April 2025.
So, what really caught my eye about this study right away is the core idea. I mean, think about it. With all the technology we're using in science classrooms now, we're generating so much data about student learning. And this research is looking at how we can actually use that data, especially with AI, machine learning, to get a much deeper understanding of what's happening and even maybe see some warning signs if students might be struggling so teachers can step in and help.
Yeah, and that's what's so important. I mean, imagine trying to guide a group of students through a really complex topic. This research is kind of offering us a way to get an early read on who might need more support and even some hints about why they might be struggling. We're going to really unpack some of the surprising things about what gives us those early clues and how accurate these predictions can be. We want to give you a real understanding of what's happening in this cutting-edge research.
Okay, so to be clear, we're mainly focused on this one research article, a really comprehensive one. It's a study where middle schoolers in physics classes used digital workbooks while they were learning about energy. And the cool thing is, the researchers didn't just look at how the students did on the tasks, but they also collected data on how they felt about the learning process and how they thought about their own understanding. They had a decent sample size, too, 214 students in total.
Our mission in this deep dive, then, is to break down those key findings for you so we can understand how well we can actually predict student learning in these hands-on, inquiry-based science settings. And we'll see how different kinds of information actually feed into these predictions, like, their actual knowledge, their feelings about it, and how self-aware they are about their learning. And I'm really curious to see how accurate these predictions can become at different points in time during the learning process. So where should we start?
Well, I think it makes sense to set the stage a bit right. Talk about the kind of learning environment they were looking at in the study. It's called inquiry learning. And for anyone who might not be totally familiar with it, basically it's where students learn by kind of acting like scientists themselves. They explore questions, they come up with their own ideas, and then they test them out. Very active, very hands-on, a lot of freedom in how they go about investigating things.
It does sound great on paper, but I mean, this study really highlights this key challenge that comes with this kind of open-ended learning, right? The students really need to be good at managing their own learning. So setting goals, monitoring their progress, and switching gears when they need to. And that is so much harder to do than to say.
Oh, absolutely. But here's where things get really, really interesting when we bring in technology into the mix. So, learning environments that use tech, like the digital workbooks in this study, can actually capture a lot of information about what the researchers call KMM processes, cognitive, affective, motivational, and metacognitive processes, while the students are learning. And then with tools like machine learning, we can start to look for patterns in all that data and potentially create these early warning systems that teachers can use.
Now, this study specifically focused on the CAM part, so cognitive, affective, and metacognitive processes, because they didn't have access to data about motivation. But the big question they were trying to answer was, can we use data about these different processes to predict which students might end up struggling, and can we do it early enough to actually make a difference? So let's talk about this study itself, like how it was set up and what information they collected.
Sure. So the study was done in middle schools in northern Germany, 214 students in grades 7 and 8. And interestingly, they had two different types of schools represented: the gymnasium, which is more academically focused, preparing kids for university, and the Gemeinschaftsschule, which is a more comprehensive school for a wider range of students. And all of them participated in a physics unit all about energy.
And instead of using regular paper materials, they had these digital workbooks delivered through Moodle, the learning management system. So that was a key part of the study, right? But these weren't just like digital versions of worksheets, right? They were designed to really make the students think critically and really interact with the material.
Yeah, exactly. And those digital workbooks were crucial for collecting the data. The researchers gathered three main types of information. First, the cognitive data, which came from the students' answers to the 36 different tasks in the workbook. And those answers were scored based on what knowledge they showed, how well they were using scientific methods, and their overall performance on each task. So that was a lot of data points, the 107 scores per student across the whole unit. They then calculated overall scores for each of these areas for each of the 5 parts of the unit.
Okay, so that gives us the picture of what they knew and how well they were using their skills. But what about their feelings and how they were thinking about their own learning during all of this?
Right, so to capture that, they use self-report measures. They asked students questions after each of the 5 parts of the energy unit, using a scale of 1 to 5. And for the feelings part, so that's the affective part, they used a shortened version of the epistemically related emotion scale, which is really cool because it goes beyond just positive or negative and actually tries to capture the specific emotions that come up during learning, things like surprise, curiosity, confusion, anxiety, frustration, joy, boredom, the whole spectrum.
Kind of like a mood ring for learning almost.
Exactly. And they also asked about how interested the students were in the material, their sense of whether they were understanding things or not, and how valuable they felt the content was. And then for metacognition, which is really about how aware they are of their own learning, they had 3 questions that they developed, 2 focused on how well the students thought they were understanding the material, statements like, I understand the content well, or I learn a lot during the lesson. And the third question was about how hard they found the tasks.
So the tasks are difficult.
Something like that. Yeah, exactly. And then at the very end of the unit, they also collected some basic background information on the students, just their gender and their parents' level of education, just to have that context.
So it sounds like they had a really good, well-rounded view of different parts of the learning experience. Now, the million-dollar question, what did they find when they crunched all this data?
Well, the main thing they wanted to predict was what they called learning productivity. They based this on the students' total scores across all the tasks. Basically, how well they ended up understanding those core concepts of energy. And they then grouped students into 3 levels: unproductive, moderately productive, and productive based on their scores.
And to do that, they used some different machine learning models, right, to see which ones could most accurately predict which students would end up in which group.
Exactly. They compared 4 different machine learning models: logistic regression, which is a good starting point; decision trees, which are a bit more sophisticated; boosting trees, specifically XGBoost, those are known to be very accurate; and then neural networks. Those are incredibly flexible, but can be a bit harder to interpret. And it was really smart to compare these because they each have their strengths and weaknesses.
So which of these models did the best job overall at predicting how productive students would be?
Well, the models that used all 3 types of data, cognitive, affective, and metacognitive, those were the most accurate overall. And among the different types, the boosting models, particularly XGBoost, those tended to perform the best.
So what about the timing of the predictions? Like, how did the accuracy change as the students move through the energy unit?
Okay, so this is where things get really interesting. The accuracy of the predictions generally increased as the unit went on, especially for the models that factored in that cognitive data, how the students were actually doing on the tasks. But here's the twist. The models that only looked at their feelings and their perception of their understanding, those showed a much slower, steady increase in accuracy over time.
Interesting. So it seems like what's most helpful for predicting changes as you go along?
Exactly. And another fascinating finding early on in the first couple of parts of the unit, the models that only considered the affective data or the metacognitive data or both together were actually just as good or even better at predicting than the models that only used the cognitive data.
So that's a big surprise, right? You would think that early performance would be the best indicator. But it sounds like students' initial feelings and how confident they felt might be more telling at the beginning.
Yeah, it is really surprising. But as the unit went on, especially by the 4th and 5th parts, the cognitive data became way more important for predicting how they'd ultimately do. In fact, a boosting model that used all 3 types of data, cognitive, affective, and metacognitive, it reached around 65% accuracy in predicting learning productivity after just the 3rd of the 5 unit parts, which was based on only the first 17 out of 36 tasks.
That's amazing. So more than halfway through, you could get a pretty good sense of who might be on track to struggle just by looking at this combination of factors, which would give teachers some real lead time to help.
Let's talk a little more about what specifically was driving these predictions at different points.
Yes, that was really insightful. So at the very beginning of the unit, the most important factors for predicting later learning productivity were the level of surprise the students reported feeling, their initial self-assessment of how well they understood the content, that I understand the content well, statement, and how much frustration they were feeling. Surprise frustration.
Yeah.
It's almost like you can picture students hitting those new ideas and maybe having a little trouble grasping them at first. And that early feeling of understanding seems so powerful.
Yeah, it really does. And that initial self-evaluation of understanding was still the most important predictor, even in the second part of the unit, followed by how much they agreed with that statement. I learned a lot during class, and again, how surprised they felt. And then we see the cognitive score from the first part of the unit starting to gain some importance by this point.
So it's like that initial sense of, am I getting this,
Yeah.
has real staying power, at least in the early stages. What happens as they go deeper into the unit and get more experience with the material?
By the third part, their performance on the cognitive tasks in that third section had become the strongest predictor overall. But interestingly, their initial feeling of understanding from the very beginning and their level of interest at that third point were still important.
So even though how they are doing starts to take over, those earlier feelings and perceptions don't completely disappear.
Right, exactly. But by the end of the unit, those scores on the cognitive tasks were far and away the most important thing in predicting their final learning productivity. So the takeaway is that how students feel and how they think they're doing, those are super important in those early stages. But as they gain more knowledge and experience, their actual performance becomes the most powerful predictor of the outcome.
Which makes sense when you think about it, but it's still fascinating to see it play out so clearly in the data. So where does this leave us? I mean, what are the big implications of all of this, both for teachers in the classroom and for the researchers building on this work?
So from a practical standpoint, this study really tells us that by paying attention to not just how students are doing on the tasks, but also their feelings and how they see their own learning, we can get a good early signal about who might need extra support, especially in this kind of inquiry-based learning, which could really help teachers decide when and how to step in and give more targeted help. And it can also give them a better understanding of why a student might be struggling. Although it's important to remember, these models don't necessarily tell us the cause of those struggles.
Right. It gives teachers more information, but not necessarily a recipe for what to do.
Exactly. As for future research, there are a few things that stand out. One, the shift in the importance of those softer factors like affect and metacognition early on, and then giving way to cognitive performance later, that's a really intriguing pattern. It'd be great to see if this holds true in other subjects or age groups or learning environments.
Makes you wonder if there's a fundamental kind of shift that happens as we learn.
Definitely something to explore. It would also be helpful to look closer at which specific emotions are most strongly linked to good learning in the long run. Which ones support that deeper understanding. And they suggest looking at more transparent AI models while the boosting models were really accurate. Having models that are easier to understand could help us see the connections between all these different factors even more clearly.
And methodologically, any thoughts on how the study was done?
Well, the study really shows us that we can use these relatively simple, understandable machine learning techniques in real classrooms and get some really useful results. They didn't need some super complicated data collection methods to find these patterns, but they also acknowledge that there's always room to improve how we measure these things, especially when we're relying on self-reports from students.
So if we were to sum up what we learned today, it seems like we can get a pretty good idea of how well students will learn in inquiry-based science fairly early on by considering their academic performance, how they are feeling about the learning, and their own perception of their understanding. And it's really striking that those feelings and self-perceptions are so informative at the beginning, while their actual knowledge really takes over as the strongest predictor later on.
What's really fascinating to me is that interplay between all these different aspects of learning and how their importance in predicting outcomes actually shifts over time. It really shows that understanding student learning isn't just about looking at how they are doing on tasks, but also about how they are experiencing the learning emotionally and how their own awareness of their learning process is developing.
A lot to think about. Now, obviously, the original research paper goes into much more detail about the specific methods and findings. So if this deep dive has piqued your interest, I highly recommend you check out the study itself. And as you read Tuning, think about how these insights might connect with your own experiences, either as a learner or as an educator.
Yeah, and how these ideas could be applied in different learning environments. There's so much potential here.
And it's clear this is an area of research that is really starting to take off. Thanks for joining us for the deep dive, and we'll see you next time.